Today we're going to learn combinations and how combinations are different from permutations. In a combination, it's a selection of objects where the order is not important. For example, if I have 3 identical prizes, so I have 3 things on my desk that are all of equal value. It's pencils, by the way. It's nothing fancy, but it's pencils. So I have 3 pencils, 3 identical prizes, and the order of the winners doesn't matter. If Sam, Joe, and Mary win a pencil, that's the same as Joe, Mary, and Sam each winning a pencil because all of them won the same thing. So the order does not matter. And instead of NPR, we use NCR. So here's the formula, which we honestly aren't going to use because it's in our calculator. So 5C3 could mean we have 5 magazines. We are going to choose 3 of those magazines to take with us on an airplane flight. The order that you put those magazines in your bag does not matter. It's just we're picking 3 of the magazines to take with us. So 5C3 means 5 objects. We are choosing 3 of them. Some keywords to look for are choose. Remember with permutations, we were looking for arrange or order. If you see the word choose, order usually doesn't matter, then it's a combination. In our calculator, you would punch in the 5 first, then your PRB button, and go over to find that NCR, and then you would type in the 3. So your screen will look like 5 NCR 3, and you should get 10. On a graphing calculator, it's in the math button. So I would type in the 5 first, and then math button, go over to the probability menu. The probability menu is kind of like the PRB button on a scientific calculator. And then we're going down to NCR, and then we can type in the 3. If you have the newer calculator, you actually can do that first. Like you can get that NCR first, and then you can fill in the blanks. If you have an older calculator, you would need to do the 5 first, then the NCR, then the 3, and it would look more like what the scientific calculator screen looks like. And your answer is 10. So take a moment, pause the video, and try 8C3 and 9C1 on your own. You should have gotten 56 and 9. Did you? Hope so. 9C1 is 9. If you think about what this means, I have 9 objects, I'm choosing one of them. Well, if I have 9 cards in my hand, how many ways can I choose just one of those cards? 9 ways. So hopefully that makes sense why that is 9. And that reminds me, on yesterday's assignment, there was 0 factorial. How many of you assumed that 0 factorial was 0? I have a feeling many of you assumed that 0 factorial would be 0 because 0 times anything is 0. But if you type it into your calculator, 0 factorial actually gives you the answer 1. So why? Why is 0 factorial 1? Honestly, this is kind of a quirk in math. According to the formula for factorials, 1 factorial should be 1 times 1 minus 1 all the way down to 1. Well, 1 minus 1 is 0, so this would be 1 times 0, which would be 0. And 1 factorial can't be 0, so this is a contradiction in math. So they basically needed to say, all right, math people, we are going to define 0 factorial as equaling 1. And the math people just decided, guess what? 0 factorial is going to equal 1 because that tiny little change makes all of our other rules around factorials work. So to make factorials work in general, they had to define 0 factorial as equaling 1. So it's just kind of a weird quirk in math. Basically, all of the math super smart people way, way, way long in the past decided 0 factorial is going to be 1. It is done. I have spoken. And that's it. So, yeah. On the following examples, let's decide if you would use the fundamental counting principle, which I kind of think of that as the blanks. That's like the license plate or the outfits where you put blanks for each item and how many items go in each blank, and then you multiply them together. Just straight factorials, that's like a permutation where you want to arrange all of them. Permutations or combinations, and then find the requested value. 11 students are competing in an art contest. In how many different ways can the students finish first, second, and third? You need to think, does order matter? Yes, order matters. So it needs to be permutations. We have, I'm just gonna write what it is. So we have 11 students. We are arranging 3 of them. 11P3 means we have 11 students. We are arranging 3 of them. You can type that into your calculator and see what that is. 64 golfers are participating in a golf tournament. They play in groups of 4. How many groups of 4 golfers are possible? Does the order matter? No. If I have a group of 4, it doesn't matter what order those 4 people are in, as long as those 4 people are in the group. So this would be 64 golfers. We are choosing 4 of them at a time. We're choosing groups of 4. So 64, plug that into our calculator, C4. There are 635,376 ways. Or how many groups there are that many groups. This is why golf tournaments ask you to sign up as your team so that they don't have to go through all the different options for arranging or choosing groups. How many ways can you pick an outfit if you have 5 pairs of shoes, 2 pairs of pants, and 3 shirts? So we have shoes, pants, shirts. 5 pairs of shoes, 2 pairs of pants, 3 pairs of shirts. That would be 30 outfits. Assuming, of course, that everything is color coordinating and it doesn't really matter which of those things you choose. That philosophy would not work in my closet. Find the number of ways you can arrange the letters of the word family. It's asking you to arrange. I see the word arrange, which means permutations. Is it asking for a specific number of letters, or is it asking for all of the letters? All of the letters. There's 1, 2, 3, 4, 5, 6 of them. If it's all of them, you can just use factorials. It's less to type into your calculator, although I think it's the same number of button presses to get to the factorial. But 6, PRB button, go over to your exclamation point, and it is 720. Find the number of ways you can arrange 2 of the letters of the word family. So again, it says arrange, which means we're talking about either factorials or permutations. But since it's only 2 of the letters, we are going to do 6 letters. We are arranging 2 of them. So permutations with NPR is total number. We're arranging a specific number of them. So 6 NPR 2, 30. A grocery store sells 7 flavors of vegetable dip. You have enough money to purchase 2 flavors. How many ways can you choose 2 flavors to purchase? Which do you think we're going to use? C? So there are 7 flavors. We are choosing 2 of them because whether you get ranch and what are other? Ranch and dill or dill and ranch, you're still getting the same 2. 7C2, 21. I'm kind of impressed that a grocery store has 7 flavors of vegetable dip because I can really only think of about 2 or 3. There are 15 students participating in a cross-country race. How many ways can they finish the race? Now, it doesn't say how many ways can they place first, second, third. It's how many ways can they finish. So how many students are we trying to arrange? 15 of them. If we're arranging all of them, that would be like 15p15, which is simply 15 factorial. By the way, 15 factorial and 15p15 are the same thing. So it's easier to type in 15 factorial. Oh, that's a really big number. So we're going to write down 1.31 times 10 to the 12th. That means that we would move that decimal point 12 places to the right, and it's going to be a really big number. We could write the whole thing out and actually move the decimal point, but I'm fine with you writing it in scientific notation like that. Is that it? That's it. Yay. All right, worksheet 2 is basically just like the examples we just did. You have to decide if you're going to use the fundamental counting principle, factorials, NPR, or NCR. So it's just practicing looking for those keywords and figuring out how to put it together to get to the correct answer.